Hello, this is the second session of a second Matrices series of the OCR Pure Core AS Fair for Maths, and we will be looking at rotations in 2 dimensions. In the last session 2.1, we looked at the 4 matrices representing common reflections. In this session 2.2, we will see that the matrices representing rotations about the origin look quite similar. Look at the matrix 0, 1, minus 1, 0. So what transformation does this matrix represent? If we were to consider the unit square, so in other words 1, 0, 0, 1, we would see that 1, 0 maps to 0, 1, and that 0, 1 maps to minus 1, 0. So for example, here, we know that this is in effect rotating around the origin. So that 1, 0 goes to 0, 1, and that 0, 1 is mapping down to minus 1, 0. But let us also consider that if this works for the triangle, the red triangle, represented by the matrix 1, 2, 5, 2, 5, 4. If we pre-multiply by 0, minus 1, 1, 0, we would get minus 2, 1, minus 2, 5, and minus 4, 5. If we draw this on this diagram, this gives us this point here, this point here, and this point here. So in other words, that triangle. Again, we can see that this represents then an anti-clockwise rotation of 90 degrees about the origin. Some people like to use something called the left-hand rule to distinguish between rotations and reflections. So, for example, if you use your left hand with your index finger pointing to 0, 1 and your thumb to 1, 0, in effect this is the unit square or the identity matrix. If you then rotate 90 degrees in anti-clockwise direction, you will find that your thumb is pointing 0, 1 and your index finger minus 1, 0, leading to this matrix here, 0, 1, minus 1, 0. In contrast, if you again start with your thumb at 1, 0 and your index finger at 0, 1 and reflect in the line y equals x, in other words, turn your hand over so that you can see your palm, you will notice that your index finger is now pointing to 0, 1 and your thumb to 1, 0, leading to this matrix here. This matrix obviously represents the reflection in the line y equals x. So in general, if you can still see the back of your hand when you use it to describe or demonstrate the transformation, then it is a rotation. But if you can see the palm, it is a reflection. If we are asked to find the transformation matrix for an anti-clockwise rotation of 135 degrees about the origin, we may wish to start by considering the unit square, or the points 1, 0 and 0, 1. So we are in effect considering where 1, 0 and 0, 1 will map to. If we then think about rotating that point 135 degrees, then we need to use some GCSE trigonometry. Obviously this is 90 degrees, so this will be 45 degrees. point 01 will also have done 90 degrees plus 45 degrees. Hence, if we draw in this line of 1 there, we know that's length 1, we know that's length 1. And we also know that using Pythagoras, and in fact it's still a right angled triangle, although it may not look like it in my rather bad diagram, that this is going to be root 2, and that the y values will therefore be root 2 over 2, or 1 over root 2, and minus 1 over root 2. Thus, we can work out what the new matrix will be. Minus 1 over root 2 and 1 over root 2 for the x and y values that 1, 0 has mapped to, and minus 1 over root 2 minus 1 over root 2 for the x and y values that 0 and 1 has mapped to. This diagram is a lot neater. However, I would still like you to think of the matrix as being minus 1 over root 2, 1 over root 2, minus 1 over root 2, and minus 1 over root 2, the reasons for which will become apparent later. You may also like to remember some common trigonometrical values that you already know, such as cos 45 and sine 45. And then we'll link those to what you think cos 135 degrees or sine 135 degrees might be. If you wish to pause and check these on your calculator, that might be a good idea. You may also wish to think about some anti-clockwise rotations for other angles and see if you can spot the pattern. Noting that all these rotations are anti-clockwise, as being in a positive direction, and that clockwise rotations are considered to be negative, let us just revisit some of the rotations we have met so far. So, for example, rotation by 90 degrees was 0, 1, minus 1, 0. Stop and think about the cos and sine values for 90 degrees. Rotation by minus 90 degrees, in other words clockwise rotation, was 0, minus 1, 1, 0. Rotation by 180 degrees about the origin, and in this case the direction doesn't matter, was minus 1, 0, 0, minus 1. By this time you may have come to the realization that actually rotation by theta degrees about the origin in an anti-clockwise direction will always be represented by a matrix in the form cos theta sine theta minus sine theta cos theta. You may wish to pause now and check the results for the 135 degrees example that we looked at previously. As when investigating the transformations that were reflections, the Geogebra file is a great and dynamic way to have a play around and investigate the transformations that various matrices may represent. As we did in the previous slides, it's useful to use the unit square, or in effect the points 1, 0 and 0, 1, which are again in effect the identity matrix, and the images, in order to help work out what the matrices will be for particular transformations. In the next session, 2.3, we will look at more transformations, for example, stretches, enlargements and shears in 2 dimensions, and the matrices would represent these.